Students, today we will discuss about the benzoin condensation reaction, Stobbes condensation and Mannich reaction. So starting our first reaction, that is benzoin condensation reaction, the self-condensation reaction of aromatic aldehyde in presence of KCN, ethanolic solution of the KCN followed by its hydrolysis and then simple heating. It will get converted into alpha hydroxy ketone, and this alpha hydroxy ketone is also called as the benzoin. So in this reaction we are getting a particular compound, the benzoin, and that's why the name is benzoin condensation reaction. Now the mechanism of reaction is very simple. The mechanism of reaction start from the step nucleophilic addition of the cyanide. Cn negative, first of all nucleophilic added to the carbonyl compound, then this particular negative portion attack on this carbonyl carbon with migration of electron from this particular bond to oxygen negative, and then transfer of this H positive to O negative, forming carbon ion. Right, this carbon ion has been synthesized because it is stabilized by because this Cn group is attached with this particular carbon. So this particular carbon ion that have been synthesized in the first step is basically a stabilized C negative, and this has been synthesized like this one. So this is your first step, that is the nucleophilic addition of cyanide ion. The second step is when this carbon ion has been synthesized, this carbon ion will attack on the another molecule of this aromatic aldehyde, on the carbonyl carbon it will attack, right? So this C negative first of all attack on this carbonyl carbon with movement of electron from this to O negative, and will form cyanohydrin of the benzoin. So this is your cyanohydrin that have been prepared in the second step. Now from this cyanohydrin there will be a rapid proton exchange. The proton from this particular hydroxyl group will be replaced and will attach itself to this O negative, and this will form OH, H, and here you will have the O negative, and now there will be replacement of this Cn negative, right? Cn negative will be replaced, and this will particularly form your benzoin. Okay, so this benzoin has been synthesized in this complete reaction. The rapid proton transfer was because of the reason that here Cn negative act as a good leaving group. So there was this step occurring here, that a proton exchange was being done, right? So this Cn negative can be eliminated out very easily. It act as a good nucleophile. So basically we are using this Cn negative as a nucleophile here, as a good leaving group we are also using it here, and that's why this is acting as a catalyst for this complete benzoin condensation reaction. So this is the reaction where we are taking only benzaldehyde. Now we can take two different kind of the benzaldehyde. For example, here we are having only benzaldehyde, and this is another molecule of this benzaldehyde in which we have different kind of molecule. So one will act as the acceptor in this case, and the second one will act as the donor. So this particular molecule here act as the donor, right? Donor and acceptor property will depend upon how far this C negative is being stabilized by the group that have been attached, and the second one is that how this particular C negative can attack on this particular carbonyl carbon, means is this particular carbon is electron deficient or it is electron rich. For example, if it will be electron deficient, then this C negative can easily attack on this particular carbon, and if this carbon will not be electron deficient, it will be electron rich. For example, some electron donating group is attached with that particular group, so the electron density on this particular carbon will be not less. That's why this C negative will now not attack on this particular carbon. So the donor and the acceptor property, that will particularly depend upon the stability of this carbon ion, and that will also depend upon the factor that how this C negative can attack on the carbonyl carbon. So here this particular moiety will act as the donor and this particular will act as the acceptor, and the mechanism will be the same. You can solve this question by doing the self mechanism, and this will be the product of the reaction. This will be the benzoin from this particular reaction. So this particular reaction is called as the benzoin condensation reaction. Now we will proceed to our second reaction, and that is, Stobbes condensation reaction. This Stobbes condensation reaction having good synthetic utility, and this is a reaction, between the dialkyl succinate and aldehyde or ketone. Okay, dialkyl succinate and aldehyde and or ketone that can be used in presence of base, and this will be the product of this reaction. Okay, this will be the product of this particular reaction, that is alpha beta unsaturated half ester, you can say it. Half ester, you can say it. This will be the product of this particular reaction. This is your ketone. Here you can also take the aldehyde as well, and this is your diethyl succinate, and this is your base. You can use different variety of base. For example, sodium ethoxide can also be used here as a base, and this will, on reaction with that particular group, will form this particular compound. Now the mechanism again will involve the enolate formation. So first of all, we will have the enolate formation, the first step of the mechanism, in which the diethyl succinate first of all react with the base, and the base will abstract the acidic proton from here. Acidic hydrogen will be removed, and this will form CH negative, which is being resonance stabilized. So enolate will be synthesized in your first step. The second step, again the nucleophilic addition of this particular enolate with the aldehyde or ketone you have taken. So here, for example, we are taking the aldehyde. So this particular enolate will now attack on this carbonyl carbon, forming this particular adduct. So this adduct has been synthesized in your second step. Now come to the third step. Third step is also reversible step, and reversible, it will form the lactone, right? And how the lactone can be synthesized? This particular O negative from the adduct will now attack on this particular carbonyl carbon in vicinity with this one, and this will form this particular group, and this when this particular electron will move here, leaving behind this ETO negative, and this will undergo the cyclization reaction and will form the cyclic ester will be synthesized, that is lactone will be synthesized. Now come to the fourth step. The fourth step in the Stobbes condensation is very important part, and this is irreversible ring opening. I will tell you the importance of this particular step here. This is the irreversible ring opening, right? Always remember, this is irreversible ring opening, in which ETO negative that has been eliminated from that step will now abstract the acidic hydrogen. So this particular hydrogen is acidic, and it will be abstracted from that one, and it will form C negative. Now from this C negative, this electron will move towards this carbon-carbon to form the carbon-carbon double bond, with migration of this particular electron CO to the O negative, and this will form half ester. Salt of the half ester has been synthesized from this step, which on further hydrolysis will form half acid. So this is your final product of the Stobbes condensation reaction. This is your final product of the Stobbes condensation reaction. Now the requirement, why this step was very important. The requirement is that should contain at least 2 replaceable hydrogen. If the replaceable hydrogens are only 1, at that time the lactone formation will be the final product, and this step will not come in force at that time if the number of hydrogens, replaceable hydrogen, are only 1. Means there are no 2 hydrogens are there and 1 hydrogen is there. At that time this step will not come into the force, so this will not be the final product. And lactone, that can be easily isolated in that case. For example, here we are using the substituted succinate, right, in which only 1 hydrogen you can see here. So here when it will react with particular aldehyde, this lactone has been synthesized and this was isolated as well, right? So this is the beauty of this reaction, and this is the synthetic importance of this reaction, that how we use this kind of particular group to do the reaction, right? So this is your Stobbes condensation reaction. Now come to the Mannich reaction. Mannich reaction is also very important reaction, and I will discuss in my in next lecture.